Hello and welcome to the lecture session on Poisson distribution. This is also a discrete probability distribution. In the discrete probability distribution, we have two types of distributions. One is a binomial, other one is a Poisson distribution. And in the continuous probability distribution, we have a normal and the exponential distribution. In the previous classes, I have already discussed about what is a binomial distribution. And today's class, we are going to discuss about what is a Poisson distribution. In this case, the Poisson distribution, the sample size will be very high, like infinite size, and the probability of success will be very low. It is almost tending to 0. So with this concept, actually we can solve the problems based for a discrete probability distribution, both with the Poisson as well as binomial distribution. So in the Poisson distribution, it is a limiting case of a binomial distribution. So in the binomial distribution, we observe that p of x is given by ncx into p power x into q power n minus x. If n is too large, that is n is tending to infinity, or the sample size is very big, and p is very small. P is nothing but the probability of success, that is p is almost tending to 0. Then np is tending to m, let us say. Then p of x is given by m power x into e power minus m by x factorial, is called the Poisson distribution, where m is the mean. So the probability distribution is a Poisson distribution is a probability function. In order to show that any distribution is a probability function, its total should be equals to 1. In the discrete probability distribution, we use the summation notation, whereas in the continuous distribution, we will use the integration symbol from 0 to whatever the limit may be. And that total should be equals to 1 in all the cases, that is whether a probability function. In order to prove that it is a probability function, it should be always equals to 1. Now, tabular form, if we take x when it is taken as 0, 1, 2, 3, etc. up to infinity, if you take, and corresponding to that, our p of m will be e power minus m into e power minus m by 1 factorial, m square e power minus m by 2 factorial, m cube e power minus m by 3 factorial, and so on, which is equals to e power minus m. That is, when you take the total of all this, we get e power minus m into 1 plus m by 1 factorial, m square by 2 factorial, and so on. This e power minus m, let it be as it is, and when we take this bracket, it is nothing but an exponential series with m here. So in place of x, if we are replacing it with the m, it is going to be the e to the power m. But here we have e to the power of minus m and e to the power of plus m, and since the bases are same, the powers gets added, and m and minus m will give us 0. So anything to the power 0 is nothing but 1, and therefore sum of p of x is given by 1. Hence it is a probability function. Coming to the mean and standard deviation of the Poisson distribution, mean is given by m, variance is given by m, and the standard deviation is always the root of the variance. Therefore, the variance is m, means the standard deviation is the root of the variance. Let's see the illustration, an example. The probabilities of a Poisson variate taking the values 3 and 4 are equal. Calculate the probabilities of variate taking the values 0 and 1. We know that probability function p of x is given by m power x e power minus m by x factorial, where m is what? It's nothing but n into p, where n is sample size and p is the probability of success. And almost n is tending to infinite and p is almost tending to 0. And it's given that p of 3 and p of 4 are equal. We can observe in the question here, the probabilities of Poisson variate taking the values 3 and 4 are equal. That is what they have given. Therefore, it is p of 3 and p of 4 are taken to be equal. Then, if we substitute the value of x as 3 and 4 in the formula, we get m cube e power minus m by 3 factorial is m power 4 e power minus m by 4 factorial. Cancelling the terms which are like, that is e power minus m cancels and m cube and m power 4 gets cancelled, and in the right hand side denominator is for 24, that is 4 factorial. Left hand side denominator is 3 factorial, that is 6. And on cancellation and simplification, we are getting the value of m as 4. So, p of x is given by 4 power x, because m is 4 here, 4 power x into e power minus 4 divided by x factorial. And they have asked us in the question, you can observe, calculate the probabilities of variate taking the values of 0 and 1. That means we need to find out what is p of 0 and p of 1. So when we substitute x is equals to 0 and 1 in the obtained formula, that is given by this one, so it will be p of x is 4 power x e power minus 4 divided by x factorial. Therefore, p of 0 is given by 4 power 0 e power minus 4 by 0 factorial, and that is nothing but 1 upon e power 4. Because 4 power 0 is 1 and 0 factorial is also 1. Next, p of 1 is 4 power 1 e power minus 4 divided by 1 factorial. That gives us 4 divided by e power 4. Let's go for the next example. The probability that the news reader commits no mistake in reading the news is 1 upon e power 3. Find the Poisson variate, and newspapers have only 2 mistakes, more than 3 mistakes, and at most 3 mistakes. Solution: from the Poisson distribution, we have p of x is m power x e power minus m by x factorial. Given the newsreader commits no mistake is 1 upon e power 3. Call this as equation number 1. If newsreader commits no mistake, then p of x is equals to 0, because x is taken as number of mistakes committed. So m power 0 e power minus m divided by 0 factorial. So it gives us only e power minus m, because m power 0 is 1 and then 0 factorial is also 1. So it gives e power minus m. Now let's combine 1 and 2. It gives e power minus m is e power minus 3, or m is equals to 3. From the Poisson distribution, p of x is m power x e power minus m by x factorial. Therefore, m we have obtained is 3. So, p of x is given by 3 power x into e power minus 3 by x factorial. Now, only 2 mistakes, exactly 2 mistakes will be there. Means p of x means p of 2. That is 3 power 2 e power minus 3 by 2 factorial, which on calculation we will be getting 0.22404. So that is the probability of committing only 2 mistakes is this much. Next, more than 3 mistakes. Here p of x greater than 3, meaning p of greater than 3, that is 4, p of 4, p of 5, p of 6, etc. It is up to infinite. It is not actually possible for us to compute that. So what we will do is we will take its complement, because total of the probability is 1. From the 1 we will take the complement of p of x greater than 3. The complement of x greater than 3 is less than or equal to 3. That is very easy to compute. So we will take it as 1 minus p of x less than or equal to 3. That is 1 minus p of 0, p of 1, p of 2 and 3. That we will easily calculate, and we will get the answer which can be taken from or subtracted from 1. So we get 0.3528. That is probability of committing more than 3 mistakes. Next, at the most 3 mistakes. So at the most 3 mistakes means we need to take less than or equal to 3, which we have the formula p of 0 plus p of 1 plus p of 2 plus p of 3. Less than or equal to is there, so we will take even p of 3 also. So we can calculate by taking e power minus 3, which is common. 3 is 3 power 0 by 0 factorial, 3 power 1 by 1 factorial, and so on. We will get 0.6472. This is the probability of at most 3 mistakes. That is, maximum is 3 mistakes, not more than that. Let's see the next example. Number of accidents in a year for the taxi drivers in a city follows a Poisson distribution with the mean is 3 out of 1000 taxi drivers. So you can observe here mean is 3. It is not probability of success, mean, that is m value, and out of 1000 taxi drivers, so that's a n. Find the approximate number of taxi drivers with no accidents in a year, that is 0 accidents, more than 3 accidents in a year. These are the things we have to calculate. Let us see how the given data is. And we know the formula is p of x is m power x into e power minus m by x factorial. Given mean is 3, hence m is equals to 3. So we have 3 power x e power minus 3 by x factorial. For 1000 taxi drivers, we have to multiply the p of x with 1000. That we will now name it as f of x. So we get 1000 into p of x, or f of x is 1000 into p of x is given by e power minus 3, 3 power x by x factorial. That is 50 into 3 power x divided by x factorial. This is on simplification, we are getting it. So we need not multiply 1000 every time. Already we have multiplied for the main function itself. So now let's calculate the number of that is no accidents. What is the probability that there will be no accidents? Or, and let's put it in another way, out of 1000 taxi drivers, how many will be so accurate that without any accident they will be able to drive that? So f of 0 it is. So let us take 0 as the value of x in the previous function, that is 50 into 3 power x by x factorial. That gives 50 into 3 power 0 by 0 factorial, which gives us 50. That means out of 1000 taxi drivers, there are only 50 taxi drivers who will be riding very carefully that there will be committing no accidents at all. Coming to the next. In this category, out of 1000 taxi drivers, how many will be committing more than 3 accidents? But here it is directly the formula, it is not applicable. Let us find out the p value first, then let's multiply with 1000. So p of x greater than 3, as I have told that p of x greater than 3 means we need to take p of 4, 5 up to 1000. It is highly impossible to calculate. Therefore, what we will do is we will take its complement, that is 1 minus p of x less than or equal to 3, we do it. That's very easy, computing only 4 numbers. So substitute in p, not in the f here. P of 0, 1, 2, 3. When we substitute, we are getting 0.35. And this is only the percentage. So for how many taxi drivers it is? It is only for 1000 taxi drivers. So we need to multiply this percentage to the number of taxi drivers. So when we do this, we are getting exactly 350. What is this number actually? There are 300 out of 1000 taxi drivers. We are having only 350 drivers who will be doing more than 3 accidents. This is what is the answer. Thank you. Any clarifications, you can please message me.